Okay, right. So we were discussing about the method of checking a relation is reflexive, symmetric, or transitive. Right. And we started the textbook exercise. We have done up to question number 6. In between, 2 questions we skipped. Am I right? So let us move on to the topic for Elsa. What do you mean by a reflexive relation, Elsa?
Reflection എന്ന് പറയുമ്പോൾ എല്ലാ ആ റിലേഷനുള്ള എല്ലാ എലമെന്റ്സ് 1 1 2 2 3 അങ്ങനെ
ഡെഫിനിഷൻ ഒക്കെ എങ്ങനെ പറയൂടാ? ഡിഫൈൻ റിഫ്ലെക്സീവ് എന്ന് പറഞ്ഞാൽ എങ്ങനെ പറയും? ഡിഫൈൻ റിഫ്ലെക്സീവ് റിലേഷൻ എന്ന് പറഞ്ഞാൽ
A1 A1 അങ്ങനെയല്ലേ
പറഞ്ഞോ, ഡെഫിനിഷൻ ഒക്കെ പറഞ്ഞോ. പഠിക്കണം. ഇത് നമ്മൾ ക്ലാസ്സിൽ പറഞ്ഞ മെമ്മറിയാണ്. ക്ലാസ്സിൽ പറഞ്ഞ മെമ്മറിന്ന് ആൻസർ ചെയ്തേ, മറിച്ച് നോക്കിയ മെമ്മറി എന്നല്ല. അതാ വിഷയം. നിമ, റിഫ്ലെക്സീവ്.
For every relation AA, there should be a mutually there should be a mutual number, same number of relations.
Same number. Kore simple namukku definition ulla unde. Harigavande. A definition is therefore reflexive. It's too simple. We can say that the relation R is reflexive if
A belongs to R.
Absolutely. That's a definition actually. A relation said to be reflexive if AA belongs to the relation. For every A belongs to us. What about symmetric? Allu, symmetric.
So for every relation A1, A2 belongs to R. Plus that A2, A1 also belongs to.
If A1, A2 belong to the relation or AB belong to the relation, then its converse BA or A2, A1 should also belong to the relation. If A1, A2 belong to relation, A2, A1 also belong to relation. Transitive, what about transitive, Maria? Transitive means?
If AB and BC belong to R, there should be A ordered pair BC belonging to R.
AB, BC belong to R implies? AB and BC in relation implies?
Sorry sir. AC belongs to R. AC belongs to R.
AC belong to the relation. A1, A2, A3 belong to relation means A1, A3 should also belong to relation. Once again, I'm reminding the point. If we can find out an example which violate the condition, the relation falls to satisfy the particular type. This type in either type, whatever it may be, whether it is reflexive or symmetric or transitive, if we can find out an example which violate the condition for either reflexive or symmetric or transitive, we can say that the relation will not satisfy that particular type. Okay, unless we cannot find out an example, the relation will be of that type. Clear on? There is an AB and BC, there is no AC. Another example, it will not be transitive. In all remaining cases, it will be transitive. Confusion. Akash, what about equivalence relation?
Sir, if the relation is reflexive, symmetric, and transitive.
If the relation is both reflexive, symmetric, and transitive, we can say the relation is an equivalence relation. Okay, fine. So yesterday we were trying question number 4. Am I right? Fourth one, so try the second one. First, start with the second one. Start with the second one. Second is confused. Second is 50. Second is over, you can try 50. So that the relation R in the set R of real numbers defined as A, B such that A S R equal B square is neither reflexive nor symmetric nor transitive. I already told you to show that a relation will not belong to a type. It is enough to show an example. Relation ഒരു particular type പെടില്ല എന്ന് കാണിക്കാൻ അതിനെ പറ്റിയ ഒരു എക്സാമ്പിൾ മാത്രം മതി. And symmetric example വളരെ സിമ്പിൾ ആട്ടോ. Symmetric is very easy. Reflexive and transitive, I think some more time will be taken. Try first. Either start ചെയ്തോടാ. ഇതിന്റെ വീഡിയോ ചെക്ക് ആയി നിൽക്കാണല്ലോ. It's enough to find out an example. ഞാൻ പോലെ അതിന്റെ വളരെ മിനിമം കണ്ടന്റ് മാത്രമേ എഴുതുള്ളൂ. നിങ്ങളത് ഫോളോ ചെയ്തിട്ടോ. കംപ്ലീറ്റ്. Have anyone got the example to show that it is not symmetric? Anyone? Anyone got the example? 30 seconds or now. Ten seconds more. 10 seconds more. Simple. Symmetric അല്ലാന്ന് കാണിക്കാനുള്ള example is very simple. Okay, ഒന്ന് പറയാം. It is not symmetric. Example to show that it is not symmetric. Maria, have you got the example?
A is equal to B square എന്നല്ലേ പറഞ്ഞേക്കുന്നത്. So
A is less than or equal to B square.
A is less than or equal to B square. A 9 ആയിട്ട് എടുത്തു കഴിഞ്ഞാൽ B 3 ആവും. എന്തായാലും
A 9 എടുത്ത B 3 ആവില്ലല്ലോ.
A 9 ആയിട്ട് എടുത്താൽ B അല്ല A 9 എടുത്താൽ B 9 ആവും.
A square എന്ന് പറയുമ്പോൾ 9 ആവും.
അപ്പോൾ അത് തിരിച്ചെടുക്കുമ്പോൾ കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യില്ലല്ലോ.
അപ്പൊ സിമെട്രിക് അല്ല എന്ന് പറയാം തീർച്ചയായിട്ടും. പക്ഷെ തിരിച്ചെടുക്കുമ്പോൾ ഈക്വൽ എന്നുള്ള കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യും. അതായത് എടുക്കുന്ന എക്സാമ്പിൾ ഏതാണ്? 3 ഓഡേഡ് പെയർ. ഓഡേഡ് പെയർ എന്ന് പറഞ്ഞ ഓഡേഡ് പെയർ 3 9 ആണോ? 3 9 എടുക്കുമ്പോ 3 is less than or equal to 9 square ആണ്. 9 is less than or equal to 3 square also. Both the condition will be satisfied. 3 ഉണ്ടാവും. കിട്ടും. സിമ്പിൾ എക്സാമ്പിൾ കിട്ടും. ഒന്ന് ചിന്തിച്ചു നോക്കിയ നമ്പേഴ്സ് വെച്ചിട്ട്. ജോയൽ
1 2 1
1 2 and 2 1. 1 2 and 2 1 can be considered. 1 2 2 1. Sorry, 1 2 will belong to our relation. 1 2 belong to our relation because 1 is less than or equal to 2 square. But 2 1 will not belong to our relation because 2 is not less than or equal to 1 square. 2 is greater than 1 square actually. So we got an example where there is an AB but there is no B. What example ഉണ്ട് ട്ടോ. ഒരെണ്ണം മാത്രമൊന്നുമല്ല, ഒരുപാട് എക്സാമ്പിൾസ് എടുത്ത്. You can take 2 3 and 3 2, 3 4 and 4 3. All these cases we can say that one of them will belong to relation while second one will not. ഇതാണ് കേട്ടോ. കുറച്ചുകൂടെ ഫാസ്റ്റ് ആവണം. Had anyone got the example for reflexive? It's not reflexive. Only one got. Are you going there any option to show that this is not reflexive?
Sir 4 2
Reflexive or reflexive? Reflexive നമുക്ക് എന്താ ഷോ ചെയ്യണ്ടേ? റിഫ്ലെക്സീവ് അല്ലാന്ന് കാണിക്കാൻ. 4 2 നമുക്ക് റിഫ്ലെക്സിന്റെ ക്രൈറ്റീരിയയിലേക്ക് കണക്ട് ചെയ്യാൻ പറ്റില്ലല്ലോ. റിഫ്ലെക്സീവിന്റെ ക്രൈറ്റീരിയയിലേക്ക് കണക്ട് ചെയ്യണമെങ്കിൽ 2 2 എടുക്കുമ്പോൾ സാറ്റിസ്ഫൈ ചെയ്യും. 2 less than or equal to 2 square. നിങ്ങൾ ഏത് പോസിറ്റീവ് നമ്പർ എടുത്താലും they will satisfy. അതായത് ഏത് integers എടുത്താലും 1, 2, 3, 4, etc. -1, -2, etc. 0, all of them will satisfy. Felix, any example?
സാർ ചെയ്തുകൊണ്ടിരിക്കണേ ഉള്ളൂ, കിട്ടിയില്ല.
Okay, Joel.
Sir, reflexive അല്ലേ? Same then. 2, 2 അല്ലെങ്കിൽ 3, 3 അങ്ങനെ.
But 2, 2 ഒക്കെ എടുക്കുമ്പോൾ കേസ് ആലോചിച്ച് നോക്കി. 2 is less than or equal to 2 square അല്ലേ?
അല്ല.
അല്ലേ? 2 square എത്രയാ?
അല്ല, അതെ സോറി.
ആണ്. അതുകൊണ്ട് ഏത്?
അല്ല, ഓക്കെ.
1 less than or equal 1 square ആണ്, 3 less than or equal 3 square. കാരണം സ്ക്വയർ ചെയ്യല്ലേ? നാച്ചുറലി അപ്പുറം വരുന്ന നമ്പറിലായിരിക്കും വലുത്. ഏത് ഇൻഡിജർ നിങ്ങൾ എടുത്താലും, ഇപ്പൊ ഈ നെഗറ്റീവ് എടുത്താൽ -3 is less than or equal to -3 square because -3 square is 9. It's a positive number.
1/2.
There it is. There comes answer. If you take 1/2, 1/2 square is 1/4. Right? 1/2 square 1/4. Clearly, 1/2 is greater than 1/4. That is, 1/2 is greater than 1/2 square. So 1/2 is not less than or equal 1/2 square. 1/2 does not belong to our relation. We obtained a term which does not belong to our relation. So we can say this not. ഈ സ്ക്വയർ എടുക്കുമ്പോൾ ആൻസർ ചെറുതാവുക. നമ്മളോട് പറഞ്ഞിരിക്കുന്നത് നോക്കി, നിങ്ങൾ ആ റിലേഷനിൽ നമുക്ക് കുറച്ച് എന്താ പറയാ ലോജിക്ക് കൂടി വേണം എന്നുള്ള പറഞ്ഞ പോലെ a less than or equal to b square ordered by ab. We know that in every case when you take the square, the number becomes larger. Right? Square എടുക്കുമ്പോൾ എപ്പോഴും നമ്പർ വലുതായിട്ടാവില്ല. 2 square 4, 3 ആണെങ്കിൽ 9, 4 and 16, 5, 25, 6, 36. Always the number becomes larger. The one and only one case where the product or the power becomes smaller is fraction. When we take fraction, or about fraction should be between 0 and 1. 1/2 and on squaring it is 1/4. 1/3 square is 1/9. 1/4 square is 1/16. In this case, the square is lesser. Square will be smaller only in the case of fraction between 0 and 1. So no term like 1/2, 1/2, 1/3, 1/3, 1/4, 1/4, etc. will be the number relation. Reason is simple. 1/2 is actually 0.5 in decimal. 1/4 is 0.25. Right? 1/2 is larger. And the example for transitivity is much more difficult. You try. There should be an AB and BC, but there is no AC. There should be an AB and BC, but there is no AC. അതല്ലടാ സൈദേ വിട്ടു പോകണോ? ക്വസ്റ്റ്യൻ നമ്പർ 2 ട്രാൻസിറ്റിവിറ്റി. Question number 2. One more minute, no? 1 more minute for transitivity of question number 2. Thirty seconds more for transitivity. Anyone got the example? Anyone for transitive? Joel.
9442.
9, 4 and 4, 2. Correct one. 9, 4 and 4, 2 will belong to our relation. Because 9 is less than or equal to 4 square and 4 is less than or equal to 2 square. But 9 is not less than or equal to 2 square. 9, 2 will not belong to our relation. So we have 9, 4 and 4, 2, but 9, 2 will not belong. This is a particular example. We can find out many examples. Minimum example. So by using these 3 examples, we can show that the relation is neither reflexive nor symmetric nor transitive. Is it clear, everyone? Everyone? Okay, let me ask one thing. Listen. Actually, in question number 2, the relation is defined in which set? Hello? Is set relation defined?
Sir, A less than or equal to B square.
That's a condition for relation. My question is, in which set the relation is defined? The relation is defined in?
Set builder form.
Sorry? That's form. Set builder form. That's also okay. Only R is a relation on set A. That's why the set relation defined. Question look at the relation is defined in?
Sir, manchlayilla.
Number relation R is a relation on set A. R is a subset of A cross A. Number definition. In the given question, in which set the relation is defined? Question just to know why you do. Question why you read the question.
Set of real numbers.
Set of real numbers. That is what I'm asking. The relation is defined in set of real numbers. So this is all. The relation is defined in set of real numbers. Suppose instead of real numbers, if the same relation R is defined in set of integers. Suppose the relation was defined in integers. Okay. Will it be reflexive or not? What do you think? Will it be reflexive also?
Reflexive.
Why? Absolutely. Absolutely. Definitely it will be reflexive. It's the same relation. Only important point. The same relation R defined as R equals to the following pair A B such that A less than or equal to B square will be reflexive if we define the relation in integers, natural numbers, etc. Even reflexive 1 by 2, 1 by 2, 1 by 3, 1 by 3 formula. Integers 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, etc. -1, -1, -2, etc. Everyone will be there. The only group which violate the condition for reflexivity is those fractions. In this fractions, it is very important. You should think about it. It is very important in which set the relation is defined. Important because when the set changes, naturally, even though the definition is same, type of the relation changes. Is it clear? Okay. Try the fifth one.
Sir.
Try the fifth one.
Sir, മനസ്സിലായില്ല sir ഒന്നുകൂടെ പറയാമോ?
Clear ആയല്ലോ? ചെയ്തേ
എനിക്ക് മനസ്സിലായില്ല.
ഈ പറഞ്ഞ റിലേഷൻ നമ്മൾ റിയൽ നമ്പേഴ്സിന് പകരം ഇന്റിജേഴ്സിലാണ് ഡിഫൈൻ ചെയ്തതെങ്കിൽ ഇവൻ റിഫ്ലെക്സീവ് ആയേനെ. റിഫ്ലക്റ്റീവ് അല്ലാത്തതിന്റെ കാരണം ഈ 1/2 ഫോമുള്ള ആൾക്കാർ ഇല്ല എന്നുള്ളതാണ്. ആൾക്കാർ ഇവിടെ ഇൻഡിജേഴ്സിലില്ല. നമുക്ക് പെർഫെക്റ്റ് നമ്പേഴ്സ് 1, 2, 3, 4 എക്സെട്ര ഉള്ളൂ. അതുപോലെ -1, -2, -3 ഒക്കെ ഉള്ളൂ. Those numbers will satisfy the condition. Everyone try fifth one. If 5 is completed, you can move to question number 7. No. 5 is completed, you can move to question number 7 and 8. Check whether the relation defined by AB such that A less than or equal to BQ is reflexive, symmetric, or transitive. Reflexive ഒക്കെ നമുക്ക് ഓൾറെഡി ഇപ്പൊ പീരിയഡിനെ എക്സ്പെക്ട് ചെയ്തു. Reflexive, symmetric ഒക്കെ ഇപ്പൊ തന്നെ നമുക്ക് ആൻസർ ചെയ്യാനുള്ള ഓപ്ഷൻ കിട്ടുന്നുണ്ടാവും. ഇല്ല ആകാശേ? Is it reflexive, A less than or equal to BQ?
No, sir.
Why?
It is real numbers limit 1/2.
Absolutely. 1/2 cube is 1/8. 1/2 is not less than or equal to 1/2 cube. So 1/2 will not belong to our relation. R is not reflexive. R is not reflexive. Similarly, we can find out an example for symmetric also, right? Symmetric on the value. Which example can be taken to show that it is not symmetric?
Sir, 1 and 2.
1, 2 can be taken. 1, 2 belong to the relation because 1 is less than or equal to 2. Because I just assume 1 less than or equal to because 1 is less than or equal to 2. But 2 is not less than or equal to 1. Therefore, 2, 1 not an element of relation. R is not symmetric. In similar way, we should find out an example for transitive also. For transitive, you have 1 minute max. Thirty seconds more. Have you got an example, Nima, regarding transitivity?
Sir, fraction height.
Real numbers, we can use fraction also.
3 by 2.
3 by 2.
3
Okay.
by 5, 6 by 5.
3 by 5 and 6 by 5 belong to the relation. We are not there. When we choose this 3 by 2, 3 by 5, 6 by 5. 3 is less than or equal to 3 by 2. 2 is okay. 1.5, 327 by 8. So okay. 3 by 5, 6 by 5 will be, that is also okay. Purple, I think. Any other example? Hello? Sorry? 3 by 2 3 by 5 on a second example.
3 by 5, sir.
3 by 5 and 3 by 2 we consider ചെയ്യാൻ ഈ രണ്ട് എലമെന്റ് സെയിം വരണ്ടേ? AB and BC അല്ലേ? Any other example? കിട്ടിയില്ല? തൊട്ട് മുമ്പത്തെ എക്സാം നമുക്ക് ക്ലിയർ ആയിട്ട് അപ്ലൈ ചെയ്യാൻ പാടില്ല. 9-4 and 4-2. Shall we apply 9-4 and 4-2? It is correct. 9 is less than or equal to 4 cube. 4 is less than or equal to 2 cube also. But 9 is not less than or equal to 2 cube. 9-4 and 4-2 will belong to our relation. Because but 9 is not less than or equal to 2 cube. 9-2 will not belong to our relation. Therefore, the given R is not transfer. Same example can be taken.
Sir,
Yes, Akash.
sir 9 ഒന്നുമില്ല
പറഞ്ഞോ, നമുക്ക് ചെക്ക് ചെയ്യാം.
ഇല്ല, എന്റെ തെറ്റിപ്പോയി ഓർഡർ. 9-4-8-2 ആയിപ്പോയി. അവിടെ 4 തന്നെയാണ്.
So I hope everyone completed, right? Fast move to question number 7. 7 ഒക്കെ നമ്മൾ ഇന്നലെ ലീവ്സ് ഇൻ ദ സെയിം ലൊക്കാലിറ്റി, വർക്ക്സ് ഇൻ ദ സെയിം പ്ലേസ് എന്ന പാറ്റേണിൽ തന്നെ എഴുതി പോകുന്നുള്ളൂ. സെന്റൻസ് simply we can sentence. 8 is also a simple one because a very small set we can easily define. Complete 7 fast. I will provide maximum 3 minutes to write the statements of 7 to 1. That's simple. It's similar to the one that we discussed yesterday regarding the same locality, same workplace, like that. A pattern of the complete on the question over. Two more minutes. Two more. One more minute. Okay, right. So, how we get the statement for reflexive, Maria?
If X and Y belong to R, X and Y have same number of pages.
That's the condition for the relation.
Yes, sir. അപ്പൊ നമുക്ക്
ആ.
എക്സും സെയിം രണ്ട് ബുക്കിനും സെയിം പേജസ് ഉണ്ടെന്ന് പറയാലോ. സെയിം നമ്പർ ഓഫ് പേജസ്.
Absolutely, we can write X and X has same number of pages because both are the same book, alle?
Yes, sir.
Therefore, ordered pair X belong to the relation. For all X in A is ingane ezhudana ട്ടോ. ഇതാണ് നമ്മൾ ഇത് എഴുതുമ്പോൾ കംപ്ലീഷൻ വരുള്ളൂ. Like this, X belong to relation for all X in A. For all ഈ symbol ഒക്കെ അറിയാലോ അല്ലേ? I hope you remember this symbol for all. That symbol is read as for all, for every, for all or for every. The symbol is read as for all or for every. This denote element of. അറിയാമെന്നാണ് പ്രതീക്ഷ. പ്ലസ് വൺ സെറ്റിൽ നമ്മൾ ഉപയോഗിക്കുന്ന സിമ്പിൾസ് ആണ്. Also, I hope the statement that I have given is clear for you. അപ്പോൾ നിങ്ങളുടെ മാത്തമാറ്റിക്സ് ടെക്സ്റ്റ് ബുക്ക് ആണ് എക്സ് എങ്കിൽ it contains 300 pages. We are considering the same mathematics textbook again. It will contain the same number of pages. അല്ലേ? Symmetric, how we can the statement Basil? Symmetric.
X and Y have same number of pages. So Y and X have same number of pages. So XY belong to R, so and YX belong to R.
Absolutely. Y and X also has same number of pages. Y comma X will belong to the relation. Therefore, R is reflexive. Therefore, R is symmetric. And how we can write about transitivity? Transitivity, how we can write Elsa?
Transitivity കിട്ടില്ല സാർ.
ആലോചിച്ചോക്കണം എങ്ങനെ ട്രാൻസിറ്റ് നമ്മൾ അസ്യൂം ചെയ്യേണ്ടതെന്ന് പറയാം. How should we assume?
3 ബുക്ക് ഉണ്ടാവും.
അപ്പൊ ഏതൊക്കെ നെയിം പറഞ്ഞു? നമ്മൾ ഏതൊക്കെ സിമ്പിൾ എടുക്കണം? 3 പറഞ്ഞു.
A B
and B C. Okay, A B and B C relation ഉണ്ടെങ്കിൽ what's the condition?
AC ഉണ്ടാവും.
AC ഉണ്ടാവണം നമുക്ക് ചെക്ക് ചെയ്യണം. A B B C ഉണ്ടാവാൻ given relationന്റെ കണ്ടീഷൻ എന്താ?
നമ്പർ പേജസ് ഈക്വൽ ആയിരിക്കും.
Number of pages equal ആയിരിക്കണം. അപ്പൊ ചിന്തിച്ചു നോക്ക്. Number of pages of A and B are same. Number of pages of B and C are also same.
A and C same ആയിരിക്കും.
അത്രേ എഴുതാനുള്ളൂ. A B and B C belong to relation. Then A and B has same number of pages. B C belong to relation. B and C have same number of pages. Therefore, A and C also have same number of pages. AC belong to relation. Therefore, the relation is transitive. And hence it is clearly an equivalence relation. Am I right, everyone? Clear? Okay. So try the 8th one. Without wasting time, try the 8th one. In 8th one, there are 2 parts for the question. You read the question carefully. Only after you should start trying. First, you read the question. You have 2 minutes to read the question carefully. Only after try starting. First, you should read the question carefully. Say that. What are you writing now?
Question എഴുതിയെടുത്തിട്ട് ഇതിനകത്ത് നോക്കി.
What's the purpose of writing the question? Do you have a textbook? Question open the textbook. No need to write the question. Exercise 1.1, page number 6. Continuation. I told you yesterday, no need to write the question. Page number 6, exercise 1.1. One moment to read the question. Okay, tell me what the question means. Harry Govind, what's the meaning of the question?
റിലേഷൻ തന്നിട്ടുണ്ട്.
Okay.
അത് ഇക്വലൻസ് റിലേഷൻ ആണ് പറഞ്ഞിട്ടുണ്ട്.
പറഞ്ഞിട്ടില്ല. Question ഒന്നുകൂടെ നോക്കി. Is it given that it is equivalence?
Is an equivalence relation.
Read from the starting. Read from the starting. No. Is it given that the relation is equivalence relation?
No.
What we should do first? According to the question, what we should do first?
Set കണ്ടുപിടിക്കണം relation.
Relation നമുക്ക് എഴുതാം. Set roster form ലേക്ക് convert ചെയ്യാം എന്നിട്ട്
show that all the elements of set
that's the second part. That's the second part. That's the second part. In the first part, what we should show?
Equivalence relation ആണെന്ന് show ചെയ്യണം.
First, we should show that the relation is equivalence relation. That's the first part. In the first part, we should show that the relation is equivalence. This is the first part. From here up to here, we should show that the relationship, the given relation is an equivalence relation. Second part is show that all elements of 1, 3, 4 related to each other, all of 2, 4 related to each other, no element of 1, 3, 4 related to no element of 2, 4. That part you will get the answer when once you write the relation into roster form and prove the equivalence part. Once you prove the equivalence part, we can easily answer the second. So first you try that. First. First of all, we should convert the set into roster form. Relation to roster. For that, let me ask one thing. Listen, given that the relation is R is equal to set of all ordered pair A, B such that modulus of A minus B is even. I wish to ask two things. First one, Alsaf, what does this modulus sign means?
Modulus number plus or minus or minus.
Above what is modulus of 5?
Minus 5.
And modulus of minus 5?
Plus 5.
No. Modulus of minus 5 is plus 5. What is modulus of 5?
5.
Modulus of 5 is 5 itself. So modulus means whatever be the number that comes inside, we will only consider its magnitude. Modulus. Modulus of minus 10 will be 10. Modulus of minus 2 will be 2. Modulus of minus 7 will be 7. Modulus of 7 will be 7. Modulus of 2 will be 2. In general, modulus means we are considering the magnitude irrespective of positive or negative. Positive or negative doesn't matter. We will take that magnitude only. One more question. What about 0? Is 0 an even number? Maria? Is 0 an even number? Even number on the start here. Sorry? ഒന്നുകൂടെ പറയാൻ വരെ എനിക്ക് ക്ലിയർ ആയില്ല. 2 മുതൽ ആണോ ആകാശേ?
Yes sir.
2 മുതൽ. അല്ലു? 2 തൊട്ടിട്ട്. Generally, we say that even number starts with 2. 2, 4, 6 എന്ന നമ്മൾ even number normally consider ചെയ്യാറില്ല, അല്ലേ? But 0 is also an even number. Just note it down. 0 is also an even number. Zero is also an even number because that idea is also required in order to answer the given question. Now try it first. I think to convert to roster form, you need maximum 1 more minute. To write the set into roster form, maximum 1 more minute will be available. Okay. Is there anyone who had not get the roster form till now? Roster form കിട്ടാത്തവർ ആരെങ്കിലും ഉണ്ടോ? Anyone? Right fast, 30 seconds more. I hope when you complete in the roster form, there will be 13 ordered pairs. No, 13 ordered pairs, I think. Is it? Okay. Maria, which are the ordered pairs?
So 1 1 1 3 1 5 2 2 2 4 3 1 3 3 3 5 4 2 4 4 5 1 5 3 5 5.
That's a good order, though. Another order on a bow, Maria follow the order elements in it completely the post so that none of them will be missed. That's a good order. Very good. This much ordered pairs will be there. 5 1 5 3 and 5 1 1. When we consider 1 1, 1 minus 1 is 0, it is an even number. 1 3, 1 minus it become negative 2. Since we are taking modulus, it will become positive 2. It's also an even number. Like now, clearly we can write. Is it a reflexive relation also?
No, sir.
No. Why?
Flexive.
Flexive. Oh, 1 is reflexive, no doubt. So the given relation is reflexive because every ordered pair A is there. There is 1 1, there is 2 2, there is 3 3, there is 4 4, and there is 5 5. Everyone are there. We can directly write it off because already we have the roster form. We can directly write R is reflexive. What about the symmetric condition? Symmetric, say, is it symmetric?
Yes, sir.
Is it symmetric?
Wait, sir. Yes, sir. Symmetric.
It is symmetric. Because there is 1 3, there is 3 1 also. There is 1 5, there is 5 1 also. There is 2 4, there is 4 2 also. Like that, there is 1 3, 3 1 also. For everyone, the opposite order is also there. It is symmetric. What about the transitivity? Nima?
Sir, transitive.
It is transitive also. It's reflexive, symmetric, as well as transitive. Now you can easily complete the second part. Second part idea kitted just read it once again so that you will get the idea. Read it once again so you will get the idea.
Sir?
Yes, Felix?
Sir, is it transitive? No?
Highlight the example now.
1 1 2 2 1 2
1 1 2 2 transitive.
Okay, sir. Okay, sir.
Second and first element should be same, no? What's the meaning of the next part that we should prove, Joel?
1 to 5 are related to itself and related
all
to
elements of 1 3 5 is related to each other and all elements of
2 4
2, 4 is also related to each other, but no element of 1, 3, 5 is related to any element of 2, 4. And that's the meaning. In Malayalam, what does it mean? Joel, what is the statement?
But condition satisfy 135 ആയിട്ട് 135 ആയിട്ട് condition satisfy 24 ആയിട്ട് condition satisfy പക്ഷേ 135 ഉം 25 ഉം satisfy ഇല്ല.
Absolutely. Every element of 1, 3, 5 is related to each other, which means there is 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, 5, 1, 5, 3, 5, 5. Then every element is related to each other. Everyone in 2, 4 is related to each other. 2, 2 is there, 2, 4 is there, 4, 2 is there, 4, 4 is there. So every element in these two sets are related to each other. But is there a 1, 2? Is there a 1, 4? Is there a 3, 1? Sorry, 3, 2? Or no? Illa. So the meaning of the question is every element in 1, 3, 5 is related to each other. Every element in 2, 4 is also related to each other. 1, 1, 1, 3. Every element in 1, 3, 5 is related to each other. Every element in 2, 4 is also related to each other. But no element in 1, 3, 5 is related to any element in 2, 4. There is no 1, 2, no 1, 4, no 3, 2, no 3, 4, no 5, 2, no 5. No direct statement. 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, 5, 1, 5, 3, 5, 5. Belong to relation. Therefore, every element in set 1, 3, 5 is related to each other. Similar way we can write 2, 2, 2, 4, 4, 2 and 4, 4 belong to the relation. Every element in 2, 4 is also related to each other. But no element in 1, 3, 5 is related to any element in 2, 4. That we can write as statement itself. Again and again, I am reminding you should ask if there is any doubt. Please don't keep mum. Don't copy paste. Don't sit in a drawing class. The drawing class at a consider. We are not copying from the board. One more minute to complete that. Let me explain one point. After that, we can move to the next question. Let's complete this first. Let's complete the question first. Over everyone, this question. Okay, now below, right? Let's say definition. Equivalence class. Equivalence class. Equivalence class. Right? The equivalence class of an element. The equivalence class. The equivalence class of an element in a relation is the set of all elements is the set of all elements related set of all elements related to that particular element. To that particular element. It means only this one. When you look into the above example. Okay, in this example, if we write the equivalence class of 1. 1 is an element in the relation, right? The relational element is 1. Equivalence class of 1 we denote in English. Normally we represent it like this. We represent here. Equivalence class of 1 and both the representation correct. It is a set containing. In the definition, it is a set containing.
Is the set of all elements related to that particular element?
All elements related to that particular element. Equivalence class of 1 means the elements related to 1. Which are the elements related to 1? Harry Govind. 1 relational elements are here.
1 1 1 3 1 5.
1 1 1 3 and 1 5. So 1 no matter relational line. 1 1 1 3 1 5 is there. So 1 is related to
3 and 5.
3 and 5 on 1 1 not related.
1 1.
So the equivalence class of 1 will be 1 3 5. 1 is related to 1 3 5. If we write equivalence class of 2, what will be the answer, Nima? Equivalence class of 2 will be the last example.
So 2 3 2 4.
Is there 2 3?
Sorry, 2 2 2 4.
2 to 2 4. So the equivalence class will be what?
2 and 4.
Equivalence class will be 2 and 4. This is what equivalence class means. For an element, a set of elements related to that one. This is what equivalence class means. So instead of equivalence class, maybe question write the set of all elements related to 1. I write the set of all elements related to 2. It means equivalence class. Is it okay, everyone? Fine. If so, let us move on to the remainder. Start. Question number 9 onwards. Complete the 9th question. Show that each of the relation R in set A equal to X belong to Z such that 0 less than or equal to X less than or equal to 12. Given by R equal to AB, mod A is multiple of 4. It's an equivalence equation. First you try the first part, then second part. Now. Try the first one, then second. Either you can find the answer by using statements, or you can convert to set build reform. It's your choice. Both were okay for us. Also, 0 is a multiple of every number. 0 is a multiple of every number. No doubt. 0 is a multiple of every number. That idea is also, it will be helpful when you try the next one.
Sir.
Yes.
ഇപ്പൊ നമ്മള് എ എഴുതുമ്പോ അല്ല റോസ്റ്റർ ഫോമിൽ എഴുതുമ്പോ എങ്ങനെ എഴുതണ്ട ഇപ്പൊ
ഓരോ പേസ് ഒക്കെ നമ്മൾ സാധാരണ പഠിച്ചിട്ടുള്ള പോലെ സെറ്റിലെ എലമെന്റ്സ് ആയിരിക്കാം
1 2 3 4 അങ്ങനെയാണോ
1 2 3 റിലേഷൻ ഡിഫൈൻ ചെയ്ത് സെറ്റ് ഏതാ
ഇതിന്റെ അകത്തെയാണോ
നമ്മളുടെ 9th ക്വസ്റ്റ്യനിൽ റിലേഷൻ ഡിഫൈൻ ചെയ്തിരിക്കുന്ന സെറ്റ് ഏതാണ്
X related to is it 0 less than or equal to x less than or equal to 12?
0 less than or equal to x less than or equal to 12 എന്ന് പറയുമ്പോൾ ഏതൊക്കെ എലമെന്റ്സ് ഉണ്ടാവും?
0 to 12 വരെ.
0 to 12 വരെ ഉണ്ടാവും. There we should check the which all ordered pairs will satisfy the condition. Which one did you prefer, roster or statement form? Try those. We can write, no problems. Which one did you try, the roster or statement method? Al-Safai, which method did you try?
Roster.
Roster, okay. What elements on the roster?
1, 4, 2, 4.
1, 4 and 1, 4 means the difference will be 1 minus 4. 3 LA. Is 3 a multiple of 4? Allah. 1, 4 or
2, 4, 2.
2, 4 marlelo. 2, 4 means 2 minus 4. 2 minus 4 2 LA. Is 2 a multiple of 4? 4 the multiples are again.
4.
For now.
4, 12.
About a rectangle on the 4, 8, 12, 16, etc. including 0. There are multiples. The difference must be a multiple of, only then we can include in the relation.
multiple.
8 is a multiple of 4. തീർച്ചയായും. So Akash, on the Barney, in roster form the set will be?
Sir, 1, 1.
Sorry?
1, 1.
Complete.
Full 1, 1, 2, 2.
0, 0 is also there now. 0, 0.
0,
0, 0, 1, 1, 2, 2, etc.
Up to 12.
Up to 12, 12. Then?
1, 9.
1, 9 will be there.
2, 10.
2, 10 will be there.
3,
11, 4, 12.
4, 12. 12.
Then? Can you complete the remaining, Maria?
Sir, ആദ്യം മുതൽ പറഞ്ഞാൽ മതിയോ?
പറഞ്ഞോ കുഴപ്പമില്ല, ഞാൻ കണക്ട് ചെയ്തോളാം.
Sir, 0, 0, 0, 4, 0, 8, 0, 12, 1, 1, 1, 5, 1, 9, 2, 6, 2, 10, 3, 3, 3, 7, 3, 11, 4,
Okay, fine.
4, 8, 4, 12, 5, 5,
Right. Complete ചെയ്തോ Maria. Fine. Clear ആണ്. Complete ചെയ്തു.
3 7 എടുക്കാൻ പാടില്ലേ? 3
എടുക്കാൻ എഴുതുന്നേ ഉള്ളൂ. ഇനിയുണ്ട്. ഇനി എഴുതാനുണ്ട്. 0, 4 is there. 1, 5 is there. 2, 6 is there. 3, 7 is there. 4, 8 is there. 5, 9, 6, 10, 7, 11, 8, 12, Then we have 9, 1, 10, 2, 11, 3, 12, 4. Then the order order sometimes will be missing. Starting with the 1, we will have 1, 1, 1, 5, 1, 5, and 1, 9. Starting with the 0, we will have 0, 0, 0, 4, 0, 8, 0, 2. I think with the 0, 4, 8, and 12, we will get 4 ordered pairs each. And with all other elements, you will get 3 ordered pairs each. Anyway, Harigovind, is it reflexive?
Yes, sir. Reflexive.
It is reflexive. Because remember, elements statement method it will be little bit easy. Modulus of A minus A is equal to 0. Is a multiple of 4. Therefore, A belong to relation, or all A belong to capital. Hence, R is reflexive. We can write the reflexivity like this. Now, let AB belong to relation. Mod A minus B is a multiple of 4. Clearly, then mod B minus A is also a multiple of 4, because in modulus, even though we reverse the terms, answer will be same. 1 minus 5 minus 4 modulus 4 hours. 5 minus 1 4 hours. So also a multiple of 4. Therefore, BA belong to relation. Hence, R is symmetric. Transitive also we can write in the same manner. Transitive also we can write AB and BC belong to relation. Modulus of A minus B is a multiple of 4. Modulus of B minus C is a multiple of 4. Therefore, modulus of A minus C. A minus C is equal to actually A minus B plus B minus C. Is a multiple of 4. AC belong to our R is transitive. Instead of writing the all elements, we can write like this also. It's an equivalence relation. If you try the roster method, mistake on that one is also correct. There is no mistake. The both ways we can answer. Second relation is very simple. Second relation. Roster form second relation. We can write the roster form easily. Very easy. Second one like a movie, shall we? Okay. Second part already simple relation. Set of all A, B such that A is equal to B. Maximum 30 seconds to write the set in roster. If completed, you can move to question number 10. No. Basically, in roster form, the set will be.
Statement.
Second one now. Okay.
A equal to B, so A belongs to R.
കുഴപ്പമില്ല, fine.
ഇതെല്ലാം റിഫ്ലെക്സീവ് രീതിയല്ലേ?
ഏതാ
ഇത് A equal B എന്ന് പറയുമ്പോ
എങ്ങനെ കിട്ടിയെന്ന് പറഞ്ഞേ?
0 0 1 1 അങ്ങനെയാണോ?
അങ്ങനെ എവിടെ വരെ വരും?
12 വരെ.
12 വരെ. Is it reflexive?
Yes.
Is it symmetric?
No, sir.
Why?
Symmetric എന്ന് പറഞ്ഞാൽ AB B ആവണ്ടേ?
AB ഉണ്ടെങ്കിൽ B ആവല്ലേ? നമ്മൾ മൂന്നാമത്തെ ക്ലാസ്സിലെ സെയിം തിങ് we are repeating. Is it symmetric?
No.
No. Felix, is it symmetric?
Yes, sir.
Why?
Because there is no example that violates the rule.
Absolutely. A relation will not be symmetric. ഞാൻ വീണ്ടും അത് റിപ്പീറ്റ് ചെയ്യുന്നു. ഞാൻ പറഞ്ഞു തേർഡ് ക്ലാസ്സിലെ വീണ്ടും റിപ്പീറ്റ് ചെയ്യുന്നത്. A relation will not be symmetric if we can show that there is an AB in the relation, but there is no BA. AB ഉണ്ട്, BA ഇല്ല. അങ്ങനെ എക്സാമ്പിൾ കിട്ടിയാലേ സിമെട്രിക് അല്ല എന്ന് പറയാൻ പറ്റും. Otherwise, it will be symmetric. Clearly, it is symmetric. And Nima, what about transitivity?
So transitive.
Why?
Violating example.
There is no example which violates. It's symmetric as well as transitive. We should write it is an equivalence relation.
അങ്ങനെ ഉദ്ദേശിക്കുന്നത് AB പോലെ എഴുതാൻ ഇല്ലാത്തതാണോ നമ്പർ?
AB ഉണ്ട്, BA ഇല്ല. നമുക്ക് 1 2 ഉണ്ട്. സപ്പോസ് 1 2 is there, 2 1 is not there. അങ്ങനെ വന്നാൽ മാത്രമേ നമുക്ക് സിമെട്രിക് അല്ല എന്ന് പറയാൻ പറ്റൂ.
ഈ വയലേറ്റ്സ് എന്ന് പറയുമ്പോ 1 1 ആ രീതിക്ക് വരുമ്പോഴാണോ?
1 1 അല്ലടാ. ഇപ്പൊ നമ്മൾ ഇതിനു മുമ്പ് ഒരു എക്സാമ്പിൾ പറഞ്ഞതില് നമുക്ക് AB എന്നൊരു എലമെന്റ് അതിൽ ഉണ്ടാവും. The relation will contain an element AB. AB എന്ന് പറയാം ഫോർ എക്സാമ്പിൾ 1 2, അല്ലെങ്കിൽ ഫോർ എക്സാമ്പിൾ 4 5, സംതിങ് ലൈക്ക് ദാറ്റ്. പക്ഷെ 2 1 ഉണ്ടാവില്ല, അല്ലെങ്കിൽ 5 4 ഉണ്ടാവില്ല. ഇങ്ങനെ എക്സാമ്പിൾ വന്നാലേ it is not symmetric എന്ന് പറയാം. Otherwise it will be symmetric. Even if there is no example, it will be symmetric. So clearly it is an equivalence relation. Is a question over, Allu? Is a question over? എന്താ അതിന്റെ ബാക്കി?
Find the set of all elements related to 1 in each case.
Each case we should write the set of all elements related to 1. എഴുതുക വേഗം. 4 first question, comma, set of all elements related to 1 is equal to first one set of all elements related to 1 will be Akash, it will be
1519.
1519. And in the second case it will be Akash?
Sir, 1
only. Move to question number 10.
Sorry, 159 എങ്ങനെ കിട്ടിയേ?
First question നോക്കിയേ ഇവിടെ. First relationല് 1 നോട്ട് റിലേറ്റ് ചെയ്ത് ആരൊക്കെയല്ലേ? മോഡ് എം എസ് മൾട്ടിപ്പിൾ ഓഫ് 4 1 നോട്ട് റിലേറ്റ് ചെയ്ത് 1 ഉം 5 ഉം 9 അല്ലേ ഉള്ളത്? 1 1 1 5 1 9 is elements relation, no?
Okay, sir.
Start question number 10. Elizabeth, last Sunday to what time did you have the class? Last Sunday?
രാവിലെ 6 മണി മുതൽ 7:45 വരെ.
Everyone try the 10th question. What is asked in the 10th one, Maria? Maria, mic കേൾക്കുന്നില്ല. ഒന്ന് പറഞ്ഞേ നിമ, what is asked in question number 10?
Sir, first one ആണോ?
10th one എന്താ question meaning totally?
സിമെട്രിക് ആണ്, പക്ഷെ റിഫ്ലെക്സീവ് അല്ല, ട്രാൻസിറ്റീവ് അല്ല എന്ന് കാണിക്കുന്നു.
We should write some examples, right?
Yes,
in order to write the example, first what we should define?
Set ആണോ?
We should define the set. നിങ്ങൾ വെറുതെ പോയിട്ട് റിയൽ നമ്പേഴ്സോ ഇന്റീജേഴ്സോ എടുത്തേക്കരുത്. It is easy if we take a small set. That is easy. നിങ്ങൾ കൂടെ ഇന്റീജേഴ്സിലൊക്കെ ഡിഫൈൻ ചെയ്യാൻ പോലെ വലിയ റിലേഷൻ കണ്ടു. സെറ്റ് ബിൽഡർ ഫോമിൽ നിങ്ങൾക്ക് സിമ്പിൾ എക്സാമ്പിൾസ് എഴുതാം. Let R is a relation on set A equal to say 1, 2, 3, 4. That is enough. We can easily define. Simple ആയിട്ട് പറയാലോ അല്ലേ? ഒരു എക്സാമ്പിൾ ഒന്ന് പറയാം ആകാശ്. For the first case, ഒരു എക്സാമ്പിൾ പറയാം റോസ്റ്റർ ഫോമില്. സിമെട്രിക് ആവണം.
2, 4, 2, 4, 4, 2.
2, 4 and 4, 2. Enough. More than enough. It's a symmetric one. There is 2, 4, there is also 4, 2. It is not reflexive, it is not symmetric. It is not transitive. Like this, you should write. Now, demo in this model, you should complete. Maximum 3 minutes you can complete. Content is
relation A equal 1, 2, 3, 4 അങ്ങനെയാണ്.
അത് നമ്മൾ ചുമ്മാ എക്സാമ്പിൾ എടുത്താൽ ഇപ്പൊ നിങ്ങൾക്ക് വേണമെങ്കിൽ 1, 2, 3 10 എടുക്കാം, വെരി നാച്ചുറൽ നമ്പർ എടുക്കാം, ഇന്റിജർ എടുക്കാം. പക്ഷേ when the set becomes bigger, നമ്മളവിടെ കൂടുതൽ എലമെന്റ്സിനെ കൺസിഡർ ചെയ്യേണ്ടി വരും. നമുക്ക് എളുപ്പമുണ്ട്, ചെറിയ സെറ്റാണ്. That's all. Two more minutes. Read fast. Can I give an example for second one, Basil? Transitive. It is not reflexive and not symmetric. Basil?
1, 2, 2, 3 and 3.
More than enough. 1, 2, 2, 3 and 1, 3. Clearly it is transitive. But it is not symmetric because there is 1, 2, no 2, 1. There is 2, 3, no 3, 2. It is not symmetric. Also 1, 1, 2, 2, 3, 3, 4, 4 are missing. It is not reflexive. Third one, Felix. Third one.
1, 1, 2, 2.
Reflexive and symmetric but not transitive. Reflexive only Felix.
1, 1, 2, 2, 3, 3, 4, 4.
So all the 4 should be there. 1, 1, 2, 2, 3, 3 and 4, 4. Only then the relation will become reflexive. Now it should be symmetric but not transitive. For an example, Felix?
Symmetric ആവണമെങ്കിൽ
it should be symmetric, but it is not transitive.
1, 2, 2, 1.
1, 2 is there, 2, 1 is also there.
അപ്പൊ 1 1 വരില്ലേ? അപ്പൊ ട്രാൻസിറ്റീവ് ആവില്ലേ?
അപ്പൊ നമുക്ക് ഇനിയും ആഡ് ചെയ്യേണ്ട ഒരു ഇതിലേക്ക് ഇനി നമുക്ക് ട്രാൻസിറ്റീവ് അല്ലാന്ന് വരുത്താൻ പറ്റും. ജസ്റ്റ് വൺ മോർ എക്സാമ്പിൾ ചെയ്തു. 2 3 3 2. Then it will be symmetric, but it is not transitive because we have 1 2 and 2 3. 1 3 is not there. Minimum 8 members എങ്കിലും എഴുതിയാൽ നമുക്ക് ഇവിടെ it is reflexive and symmetric, but not transitive എന്നുള്ള കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യും.
സാർ ഇവിടെ മൂന്നാമത്തേല് 1 1 2 2 3 3 4 4 എന്ന് എഴുതിയിട്ട് അത് റിഫ്ലെക്സീവ് സിമെട്രിക് എന്ന് പറയാൻ പറ്റില്ലേ?
ട്രാൻസിറ്റീവ് ആണല്ലോ. അപ്പൊ it is transitive also no.
അങ്ങനെ
1 1 2 2 3 3 4 4 മാത്രമേ ട്രാൻസിറ്റീവ് ആവില്ലടാ. വയലേറ്റ് ചെയ്യുന്ന എക്സാമ്പിൾ ഉണ്ടോ? It will be reflexive, symmetric as well as transitive.
സാർ
അപ്പൊ
ഈ 2 1 2 1 2 2 1 ഇതിലെങ്കിലും കുഴപ്പമില്ലല്ലോ.
ഏത് 2 3 3 2 മാത്രം എഴുതിയാലോ? അപ്പോഴും പറ്റില്ലല്ലോ. Because if you write only 2 3 and 3 2, what happens? 2 3 is there, 3 2 is there, 2 2 is also there. It will become transitive.
Okay, sir.
Complete the fourth one fast. Reflexive ആണ്, transitive also, but not symmetric. If it is reflexive, immediately we can write 1 1 2 2 3 3 4 4. It should be transitive but not symmetric. I think it is simple. Joy.
Fourth one. 4 3 കൂടി. 4 3 കൂടി.
Include only 4 3. അപ്പോൾ ട്രാൻസിറ്റീവ് അല്ല എന്ന് പറയുന്നത് എങ്ങനെയാ? How we can say it is not transitive? Sorry, transitive ആവണം. Transitive ആവണം. Symmetric ആവരുത്. This is enough. Fine. That is enough. Because there is 4 3, there is no 3 4. It is not symmetric. That's fine. ഏതെങ്കിലും ഓർഡർ ഇൻക്ലൂഡ് ചെയ്താൽ മതി. ഒരു 1 2 ഇൻക്ലൂഡ് ചെയ്താൽ മതി. It's okay. If you include 1 3, it's okay. Something is only required.
Sir.
Yes, പറഞ്ഞോ ചെയ്തേ.
1 2 2 3 1 3 എഴുതാൻ പറ്റില്ല മറ്റേതിന്റെ അകത്ത്.
ഡയറക്റ്റ് എഴുതാം, ഒരു കുഴപ്പമില്ല. That's also correct.
അപ്പൊ രണ്ട് ട്രാൻസിറ്റീവ് ഉണ്ട്.
ഇല്ല, അത് പ്രശ്നമില്ല. ഇപ്പോ ഇങ്ങനെ എഴുതുന്നതും പ്രശ്നമൊന്നുമില്ല. 1 1 2 2 3 3 4 4 is there. Then we are taking a 1 2, a 2 3 and a 1 3. Then also it is reflexive and transitive but not symmetric. We can write many more examples. That's your choice. Maria, last one. Symmetric and transitive but not reflexive.
So, 1 3 3 2.
1 3 3 2.
1 2 add ചെയ്തു.
1 2. Then symmetric ആവാൻ ഇപ്പൊ reflexive ആയി. Sorry, transitive ആയി. Symmetric ആവാൻ if 1 3 is there, there should be
1 3 3 1 add ചെയ്യണം.
3 1 should be there.
1 2 ന് 2 1 add ചെയ്യണം.
2 1 should be there. 3 2 ന് 2 3 വേണ്ടേ? 2 3 ക്ക് 3 2 കൂടി വേണ്ടേ?
സർ പക്ഷേ ഈ 1 3 3 1 കൂടെ ഇതാവുമ്പോ അവര്
1 1 വേണം.
1 1 വരാൻ പാടില്ല. 1 1 ഇതാണ്.
1 1 വേണം. 3 2 2 3 ഉള്ളപ്പോൾ 3 3 വേണം. 2 1 1 2 ഉള്ളപ്പോൾ 2 2 വേണം. ഇങ്ങനെ പോയിക്കൊണ്ടിരിക്കും. one second. പറഞ്ഞോ ചെയ്തേ.
1 3 3 1 1 2 2 4 1 4 എന്നല്ലേ?
1 3 3 1
1 2 2 4 1 4.
ലാസ്റ്റ് വൺ അല്ലേ? ഇങ്ങനെ വരുമ്പോ 1 3 3 1 ഉണ്ടെങ്കിൽ 1 1 വേണം. എങ്കിലല്ലേ ട്രാൻസിറ്റീവ് ആവുള്ളൂ.
Okay.
Hariko, how you got?
1 2 2 3 1 3 3 1 3 1 2 2 3 1 2 1 3 2 2 2 1 1 3 3.
Okay. Shall I tell one example? Shall I? Akash, പറഞ്ഞോ.
സാറ് പറയാൻ വേണ്ടി ഞാൻ തോന്നുന്നു 2 3 3 2 2 2
2 3 3 2 2 2 R is equal to 2 3 3 2
2 2.
Oh, that's enough. It is reflexive because 2 3 is there, 3 2 is there. It is sorry, it is symmetric. 2 3 and 3 2 is there. Transitive also. It is not reflexive. Now, suppose I am writing 1 1. Is it reflexive? Is the given set reflexive? Oh no, is it reflexive?
Sir.
No, because there is no 2 2, no 3 3, no 4 4. Right? Is it symmetric? Is the given one symmetric? Oh no, Nima, is it symmetric?
Yes, sir.
Definitely it will be symmetric because there is no example which violate the condition. Is it transitive? R equal to ordered by 1 1 or R equal to ordered by 2 2 or R equal to ordered by 3 3. It will be symmetric and transitive but not reflexive. All these are certain ideas to all the certain ideas. നമ്മൾ കുറേ സംഗതി പാക്ക് ചെയ്യണം. നമ്മൾ കുറേ ഐഡിയാസ് കുറേ കോൺസെപ്റ്റ്സ് നമ്മൾ അക്വയർ ചെയ്യുന്നതാണ്. അപ്പൊ നമ്മൾ മനസ്സിലാക്കി വേണം റിഫ്ലെക്സീവ് ആണോ ഇന്ന ആൾക്കാർ വേണം, റിഫ്ലെക്സീവ് അല്ലേ ഒരാൾ മിസ്സിംഗ് ആയാൽ മതി. Like that we should think about it. Ask if there is any doubt at all. Also you can try different example. No need to copy paste this one. You can try your own example. No problems. Examples എപ്പോഴും നമുക്ക് റോസ്റ്റർ ഫോം ആണ് എളുപ്പം സെറ്റ് ബിൽഡർ ഫോമിനേക്കാൾ. And one more thing, if the set becomes bigger and bigger and bigger, it will be difficult to get the examples. കാരണം അവിടെ നമ്മൾ റിഫ്ലെക്സീവ് വരുമ്പോൾ എല്ലാ എലമെന്റ്സിനും ഇൻക്ലൂഡ് ചെയ്യേണ്ടത്. That's a difficulty. Okay. Now within the lesser time we cannot complete 11, 12 or anything like that. You just try question number 15 first. It's an easier one. Just looking into the relation, we can claim whether it is which option will be correct. 15 to 1 now. 15. First, 15 to 1. R is defined on 1, 2, 3, 4. Whether R equal to 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2. With the correct answer. Right fast. Okay, which option will be satisfied, Hari Govind?
Option B.
Option?
B.
B. R is reflexive and transitive but not symmetric. Anna. 1 1 is there, 2 2 is there, 3 3 is there, 4 4 is there. So it is reflexive. R is reflexive. 1 2 is there, but there is no 2 1. There is 1 2, but there is no 2 1. So it is not symmetric. Also 1 2 1 3 3 2. By using those examples, we cannot find out an example which violate a transitivity. 1 3 is there, 3 2 is there, 1 2 is also there. So it is transitive. So R is reflexive and transitive but not symmetric. Clear, everyone? Okay, then fine. Remaining we will discuss tomorrow. The same. Thank you.
Thank you, sir.